Hello pre-calculus students, this video is for chapter 6.3. We are at the last video about composition of trig function and its inverse. So normally if I have a sine and cosine function composite with the inverse cosine function of sine, cosine, arctangent, they would just cancel each other and they would equal to x. So, but only if x is between 1 and -1, because that is the domain, that is the range of sine. So if you have sine inverse of a number that's outside of -1 and 1, there's no real number. So you can't just blindly cancel them. You want to make sure that your input is between 1 and -1 for sine inverse or cosine inverse. So this is very easy to do. But for a sine inverse composite with sine or cosine inverse composite with cosine, tangent inverse composite with tangent like this, then you also need to make sure that the x is in the restricted domain of the restricted sign of sine. So for a sine, it has to be, your angle has to be between -pi/2 to pi/2. For cosine, has to be this. Tangent has to be quadrant, quadrant 4, quadrant 1, -pi/2, pi/2. So for generally, if you have a sine, cosine, tangent outside and then the inverse inside, you can just cancel most of the time if these numbers are valid number, especially for tangent, it's just all real number. But if you have a sine inverse or cosine inverse and tangent inverse outside, you have to check the angles. It is really in this domain. If it is not, then what do? You just find the value that you have and then just do the sine inverse or cosine inverse, or convert it into a restricted domain value and I have the same trig value. So let's do it. Okay, so sine inverse square root 2 over 2. Check square root 2 over 2 is something that is between 1 and -1. So if this is okay, then I can just cancel it. Tangent, you almost can cancel it because cancels, there's no restricted domain. So they will cancel each other and you have -3. For this, you need to make sure that it is between, this input x has to be between -1 and 1, so which is yes in this case. Now the rest of these, C, D, E, F, all these have the sine inverse outside. Then you have to check the restricted domain. So if this angle is in the restricted domain, for sine, the restricted domain was, maybe I'll spell it out here. For sine inverse, the restricted domain for sine, for sine x, the restricted domain is -pi/2 and pi/2. And also for tangent, the restricted domain is -pi/2, x pi/2. But for cotangent, the restricted domain is for 0 to pi, because it's quadrant 1 and 2. So let's look at pi/3. Is this in the restricted domain? So you just cancel it, and the answer is pi/3. Sine inverse, 2 pi/3. 2 pi/3 is not between pi/2 and -pi/2 and pi/2, so that is outside. So I would actually have to do it. I usually just do it. So what is sine 2 pi/3? So go to the unit circle and look at 2 pi/3. Look at the sine value of that. The sine value is a positive pi, with 3/2, so with 3/2. And then I do the sine inverse, which is here, right? So that is pi/2, pi/3, because both of these has the same sine value. The same for cosine inverse. So cosine 2 pi/3, is it between 0 and pi? That's yes, right? So this is within the restricted domain, so it can cancel, and it is 2 pi/3. But if I do 7 pi/4, which is here, it is not within this restricted domain of 0 to pi, so I have to do it. I have to do cosine inverse and actually evaluate what is cosine 7 pi/4. 7 pi/4 cosine is here. The value is root 2 over 2, negative root 2 over 2. For cosine, we do the root 2 over 2. And then for cosine inverse, root 2 over 2 is pi over 4 because I reverse lookup in the first quadrant. And then for tangent, is pi over 4 within negative pi over 2 to pi over 2? Yes, right? It's in the restricted domain, so they can cancel and just be pi over 4. But 4 pi over 3 is not within this restricted domain, so I have to actually do it. So I would say, okay, do tangent inverse later, but let's do a tangent 4 pi over 3. What is tangent 4 pi over 3? 4 pi over 3 is over here. Tangent is negative, what? No, it's positive root 3. Let's look at. Tangent is y over x, so that is root 3, positive root 3, because this over this is root 3. Now, once we know root 3, when we would actually do the arctangent root 3, which is in the first quadrant, that is equal to pi over 3. Okay. We can also do composition. Okay, so I want to say for these, this will be taught again in Math 187. So I'm not going to test it. This is just for teaching you, for people that do not take 187, but this won't be in the final. For composition of two different trig functions, so sine but then cosine inverse, you obviously cannot just cancel them. So to do this, we would use a right triangle. We would use a right triangle, yes. So we would just say, okay, cosine inverse is an angle. So let cosine inverse 4 over 5 equal to an angle. And then that means if I cosine this angle, that is 4 over 5. And because of that, I can draw a right triangle, draw the angle here, and do cosine ka, A and H. So adjacent to this angle is 4, and this is 5, right? So I have the angle, I represent these things as a right triangle. Now, because I let this be theta, I'm now going to do sine theta. Okay, to do sine theta, that's O, saw, O and H. I have H, but I don't have O, so I need to solve for B. B squared plus 4 squared equal to 25. So B squared is equal to 25 minus 4 squared. B is square root of 25 minus 16 is equal to square root of 9 is equal to 3. So now I'm going to do sine theta because the question is sine theta. So sine theta using O over H would equal to, now I know O is 3, be 3 over 5. And I'm done. So this is the final answer. So when you do a composition, you're actually drawing use a right triangle to do. So again, cosine of a tangent inverse. So this is an angle. And then you would write tangent of this angle is equal to 5 over 12. Okay, and then write a triangle that say, this is the theta. I don't know what it is. You don't need to solve for it. But if I tangent it, is TOA. TOA is OA over A, which is 12. So now I don't know C. I need to solve for C. Square is equal to 5 square plus 12 square. C would equal to square root of 25 plus 144 equal to square root of 169 equal to 13. Okay, so now I know 13. But the original question would be doing cosine theta, right? Tangent inverse 5 over 10 is theta, so tangent theta equal to 5 over 10, but I want cosine theta. Cosine theta would be ka, A over H. My A is 12, the H is 13, so this is cosine. This is the answer, exact value of tangent inverse 5 over 12. Number 10, you can actually, if you exist in the domain of -1 to 1, you can actually solve for a expression which is used in calculus. So I have a sine inverse of x. So I say this is an angle, and I have this angle saw, sine for saw, O over H. Sine of this sine of these things is equal to x over 1 because x means x over 1. So O is x, hypotenuse is 1. So I have b that is missing. B squared plus x squared is equal to 1 squared. So x squared would be equal to 1 minus b. No, I need b squared. X is something that I have given. B squared is equal to 1 minus x squared because 1 squared. Then b is square root of 1 minus x squared. I write it down. B equal to, okay, I'm going to erase this. You let this, then you say sine theta equal to x over 1, and you get that. So b would equal to square root of 1 minus x squared. So now tangent of sine inverse x would equal to tangent theta, right? Tangent theta is what, according to this triangle, tau x over b, 1 minus x squared, and that's it. Find the expression for cosine of sine inverse x over 3. So again, this is theta. So that means sine theta is equal to x over 3. Use this to draw a triangle, a right triangle of x over 3 because saw, right? Okay, so I need to solve for b again. B squared plus x squared is equal to 3 squared, meaning I want to solve for b, right? B squared is equal to 3 squared minus x squared or 9 minus x squared. That's b squared. B is equal to square root of 9 minus x squared. I take positive. I don't do plus and minus because this is a right triangle. It's positive. So I get b. Now I am to find cosine of sine inverse x over 3. Is this the same as finding cosine theta? What is cosine theta according to this triangle? Car, right? Car A over H. So it's B over 3, but B is square root of 9 minus x squared over 3. So this is my answer. So that is all for 6.3, but for composition of trig and inverse trig function.